Okay. By Sunday, I'll be giving you an assignment. With that particular questions, you have to combine what I'm going to inform you as today's assignment, combine it, and then you have to submit it by next week. Okay. So today's topic, right? I'm moving back to the context-free grammar. And then in the context-free grammar, right, I have to explain you one concept about a parse tree or derivation tree. And so I'll be explaining that one. Oh, why we need to understand. First, let me explain you this parse tree or derivation tree concept. After understanding this one, right, I'll be showing you where and how we are going to utilize this concept. Okay. So definitely we're going to use this concept somewhere. I mean, in the continuing session. So before that one, I'll be explaining what do we mean by parse tree. So when I mention the name itself, right, it's a tree, it's a type of tree. The name of the tree is parse tree, or either you can call this one as derivation tree. And then I don't know whether you guys have already studied data structure and all in that trees are there. When we talk about trees means you guys might be familiar with root, interior node, then leaf node like that, okay? So those concepts, like by name, by default name, tree itself is indicating the use of roots, then leaf nodes, then internal nodes. So let me take a small example of a tree. Okay, this is a tree. This circular portion is indicating the knot. This knot might be having many features. I don't know, depends on the type of tree. So this is the initial, this one is known as root, this is known as leaf node, this is known as leaf node, then this is known as internal node. Okay, this was the concept I was telling. Now, regarding this parse tree, right, or derivation tree, let me just take one example and then explain it like that. Let me take one example. I have told this is related to context-free grammar. So let me take an example of a context-free grammar. All the capital letters are representing non-terminals. Okay. Now, how to construct a parse tree or derivation tree for this particular context-free grammar means it has to, like when you're going to derive something, when you're going to derive some string or many type of string, you have to always start from the start symbol, right? This already discussed before. So let me start from the start symbol of this. This is S. The start symbol is S. So let me write S, and then S could be derived. S could be replaced by 0B. S could be replaced by 0B. So I'm just writing this S, right? This S is going to be the root node. So let me write S inside this node. And inside this is going to be 0. Inside this is going to be B. Okay, and then any other node is derivable when after scanning the provided context-free grammar to us. Yes, B could be replaced by 0AA. So now let me derive from this one. When you study compiler and all, you'll be utilizing this concept. 0 A E. Again, from this leaf node, from this node, right? Can I able to derive a few of the nodes? Yes, A could be derived either by 1 AA or epsilon. It's up to you whether you can choose this A to be deriving, replacing by 1 AA or else by epsilon. It's up to you. So mine, what I'm going to do is I'm going to replace this A 1 A A, okay, 1 AA, and then this A by epsilon. Any other node which could be derived by any symbols or terminals when we scan the context free grammar? Yes, A. So in my case, I just want to stop this derivation. So instead of using A replaceable by 1 AA, I just want to stop it here. So let me just write epsilon. And then last time, remember, when we were trying to derive certain string from a given context-free grammar, what we did, how we used to learn in the previous classes. Let me just use that concept also. 0B, and then B is replaced by 0 AA, and then after that, what I did, this A is replaced by 1 AA, and then 001 AA. This A is replaced by epsilon, and then next this one 001 epsilon A, and then 001 epsilon. You can write it or else you can leave it like this one. Okay. So now this is the string I can derive using this particular context-free grammar, using this particular context-free grammar production rule. Now, what I'm going to do is how to, from this particular parse tree, which I have constructed using this provided context-free grammar, how to find the derived string from the given or constructed context-free grammar means you have to read the leaf node. You have to read the leaf node in this manner. In this manner, starting from 001 epsilon epsilon epsilon. 001 epsilon epsilon epsilon. Epsilon is nothing but null, so 001. Okay, that is the way of constructing a parse tree or a derivation tree from a given context-free grammar. So this is the way how to construct a parse tree or a derivation tree. Now, regarding this parse tree or derivation tree, right, there are two types. Like derivation tree or parse tree, they are of two kinds. One is known as left derivation tree. Another one is known as right derivation tree. This is of two types. Let me just write here. Number one, left derivation tree. Number two, right derivation tree. Or it may be left parse tree or right parse tree. Okay. Now let me just write. Let me just take one example, and then I'll be constructing the left derivation tree. Left derivation tree. Let me take one example. Okay. Now this is the context-free grammar provided to us. Now let's try to derive. let's try to derive A, B, A, using the given context-free grammar. Okay. Now, how I'm going to derive means I'm going to derive how we are going to derive and how we'll be constructing the tree. It's almost the same. So first, I'll be deriving the string first using the left derivation tree concept. After deriving that one, I'll be constructing the left derivation tree. Okay. So now let me begin with. In order to begin with, I should always start from the start symbol. So out of this tree, right? Out of this tree, I mean, S could be replaced by A, then capital A, then S, or this or this. So in my case, in order to generate this one, I'll be using S. Okay. Now, when can we call a derivation as left derivation or a left construction of left derivation treatments? See in here, right? In here, two non-terminals are here. When S is replaced by terminal A followed by two number of non-terminals, for deriving for replacing this capital S out of this two, either by this or this, it's up to us. It's up to us. Like either this one has to be selected for next derivation, or either this one has to be selected for next derivation. It's up to it depends on me. Okay, but in the case of left derivation tree, right, out of these two non-terminal, you have to select the leftmost non-terminal. You have to select the leftmost non-terminal. So now, in my case, leftmost non-terminal means capital S. So this one, I'm underlining it. So this S, I'll be replacing this one by ASS. Okay. Now my target is to generate this one, so I've replaced this S by this. Now again, let me just use like this. Whichever production rules I'm using, right, I'll just write it here. Now next one, right, in order to derive, in order to replace one of the non-terminal, right, again I need to select the leftmost part, so let me select A. So A, and then instead of capital A, right, I have two options. Either A could be replaced by capital S, terminal B, non-terminal A, or else terminal BA. So in my case, I'm going to use BA, terminal BA. A replaced by BA. And then next one, in order to replace this one, right, in order to replace this one, I have to select one of the non-terminal. In my case, I'll be selecting this one. This is the leftmost non-terminal. This is the leftmost non-terminal. So I'll be selecting this one. So now for this one, AABA, I'm going to use ASS. S replaceable by ASS. I'm using this one. Now again, for replacing something from this one, right, I'm selecting the leftmost non-terminal. This is capital S here. I have underlined it. Now AABAA, and then S, I'm going to replace by epsilon, which is this one. Okay, because our target string is AABA, which is already present here. So rest we have to replace by epsilon. So let me take it. AABAA, this one epsilon, as replaceable by epsilon. At the end, this is AABAA. Okay, now I have already derived the target string from the given context-free grammar by using this left kind of derivation. Now I'll be constructing the left derivation tree. Now I'll be constructing the left derivation tree. Let me use different color for this. Let me use left derivation tree. So initially what I did, initially this S could be replaced by S could be replaced by terminal A, non-terminal S, non-terminal S. Okay. And then next what I did, I've replaced this, oh, I have replaced this S, I have replaced this S by A terminal, terminal A, non-terminal A, non-terminal S. And then next what I did, this A, capital A is replaced by B, A, terminal B, terminal A. Okay. And then next what I did, instead of this S, instead of this capital non-terminal S, right, I have used A, capital S, capital S I have used. And then after this, I have replaced this by epsilon. I have replaced this by epsilon. And then I have replaced this by epsilon. And then how to check what is the derived, what is the derived string from this left derivation tree is, yeah, you should scan from this to this way, which is A, B, A, epsilon, epsilon, epsilon. This you cannot, you can leave it, this one without writing also. This is the way of constructing left derivation tree for this particular given grammar. Okay. So while the main concept is nothing but whenever you're deriving something right, you're just selecting the leftmost non-terminal and then deriving it. That's the concept. Okay. Now, now again, next one, right? What I'm going to do? Let me use. Okay, let me just delete it. For the same example, right? Let me just try to construct the right derivation tree. Okay. The same example, let me just try to construct it. Go again, it's stuck. So for this, the same example, right? Left derivation tree completed. For the same example, let me just, okay, fine, let me just write it here. Next one is right derivation tree. Next one is right derivation tree. Right derivation tree. Then let me write the example here again. S epsilon, then A has terminal B, then non-terminal A, and BA. Now you have to generate a string which is A, the same. Now the thing is you should be doing it in the right direction tree kind of way. Okay. So now always as usual we have to start from the start symbol. Let me just start from the start symbol. And then as per my target, right, I'm going to use this one. Let me just write here. I'm using this ASS. So in this case, right, what we are going to do, instead of selecting the leftmost non-terminal from the, derived non-terminals and terminals present on the right-hand side of the production rule, we are going to select the rightmost non-terminal. So in this case, the rightmost non-terminal is this one, which one is, I've underlined it here. So now this will be AS and then A terminal A, non-terminal A, non-terminal S. So I'm writing it here, this. Okay. For every derivation, we are selecting the rightmost non-terminal. Now out of this, right, again, I have to select the rightmost non-terminal, which is this one, A as A, and then I'm going to write this. Oh. So I'm using as replaceable by this. And then next one is again the rightmost one. I'm selecting here This is A as A as epsilon. This one I'm writing. And then again, the rightmost part, I'm underlining it. A as A epsilon. This one. And the next one is the rightmost non-terminal is A. So in this case, A as A, and then here I'll be using BA. Terminal B followed by terminal A, this one. So I'll write BA. So next one is this. Next one is this. So epsilon A, B, A, A. Here I'm using epsilon A, B, A. Okay. So it's simple. It's simple. We are selecting the rightmost non-terminal for derivation. That's it. Now let me construct the right derivation tree. Let me construct the right derivation tree. Start from S, which is replaced by terminal A, non-terminal S, non-terminal S. Next one is, I'm replacing this S by A, non-terminal A, non-terminal S. And then next, what I'm doing it, I'm replacing this S by terminal A, non-terminal S, non-terminal S. And then next, what I'm doing is, I'm replacing this by epsilon, next again by epsilon, and then A by terminal A, not A, terminal B, terminal A. Whichever are in the same level, you should maintain the level, okay? Maintaining the level is very important because sibling relation, that and all, you should not break it. That's why. And then next, this S, right, is replaced by epsilon. Now, if you want to check what are the derived string from this, right, derivative tree means A, epsilon, A, B, A, epsilon, epsilon. In this case, A, B, A. Okay, so this is the way of constructing right derivation tree. Now, our target topic is, ambiguity, in grammar. Ambiguity in grammar. Uh, certain words are there, right, in our language, which can mean two different ways. Okay, so in layman terms, right, what do we mean by ambiguity in grammar or ambiguous word means? Same word, if you pronounce it in different way or something, you can have a different way. Okay, so for those who are working in natural language processing and all, they'll be giving much preference to this ambiguity in grammar concept and all. If you have this ambiguity in grammar, it will bring lots of confusion for the language developer. That's why we have to remove that one, remove this one. And then let me tell you one thing again. We all know that for a given grammar, you cannot derive a unique string. You can derive many string, but you cannot maintain the unique structure. So why can't we maintain the unique structure means because of ambiguity in grammar. So context-free grammar, right? Few are ambiguous in nature. Let me just write ambiguous. Let me just write ambiguous in nature. When can we call a context-free grammar? When can we call a context-free grammar is ambiguous? Ambiguous means for a given context-free grammar, if you could design more than one left derivation tree, more than two. I say more than two or more than two or more. Okay, if you could derive, uh, if you could construct a left derivation tree more than two, or right derivation tree more than two, then you can say that this particular given grammar is ambiguous in nature. And then you should remove that one. You have to remove that ambiguity from that particular context-free grammar. And then if in exam, right, I'll say like, given the example, this context-free grammar, say whether this particular context-free grammar is ambiguous in nature, like that I'll ask. Okay. And then if I ask in that way, right, what you need to do is you should try to generate more than two leftmost derivation tree, or else more than two right derivation tree. If you could design like that, then you can conclude that the given grammar is ambiguous in nature. Okay. And then being a language developer, or if you're going to work with language and all, you have to remove that one. So how to remove that one? You have to do it as an assignment. But let me take one example to show that a given context-free grammar is ambiguous grammar or not. Let me take an example. Let me just take one example. We are going to check whether this particular given context-free grammar is ambiguous or not. Okay. And then the string to be generated is A plus this one. Okay. Now, my target is I'll be using this left derivation tree. Left derivation tree. And one more thing, there's a confusion. Many people will think that for a context-free grammar, if you could design one left derivation tree and another right derivation tree, then the grammar is ambiguous. Like that, people used to get confused in that way. No. For a given context-free grammar, if you could derive more than two left derivation tree, or more than two right derivation tree, then you have to say like, this is ambiguous in nature. Instead of saying more than two, right, let me just write two or more, or I'll just say more than one. More than one will be very accurate. More than one. Okay. Now see here, I'm going to derive. Either I can replace S using this or this, it's up to me. So I'm using this one. Then leftmost derivation means always choose the leftmost non-terminal. So I'm choosing that one plus S. Now for this one, the leftmost non-terminal is this one, which is S, this. Now again, the leftmost for this one is A, S. And then the leftmost for this one is A plus A, B. This is one derivation using leftmost derivation way. Another one I'm going to do, but I'm deriving the same, I'm generating the same string. This one. Again, leftmost non-terminal, which is this one. So S plus S, this one. And then the leftmost derivation tree, the leftmost non-terminal is S. So A plus S, this one. Again, leftmost non-terminal is this one. So this. And then the leftmost non-terminal is this. So A plus A, B. Now let me construct the corresponding left derivation tree for this two, because while deriving this A plus A asterisk B, I have used the leftmost way of derivation. For this one also I have used the leftmost way of derivation. This is two kind of deriving a plus a asterisk b, a plus a asterisk b string using the same leftmost derivation way, but it's different. Both are different. So let me draw the leftmost derivation tree. In this, it starts with s replaceable by s plus s. And then A is replaced by terminal A, and then S is replaced by S asterisk S, and then in here this A is replaced by A, and then B S replaced by B. This is one leftmost derivation tree, and then for this one, right, S is replaced. It's too big. S is replaced by S asterisk S, and then next this S this S plus S, and then this S is replaced by A, is replaced by A, and then this is replaced by B. You have seen, right? This is first leftmost derivation tree. This is second leftmost derivation tree. For a given context-free grammar, for generating the same string, if you could design more than one left derivation tree, then you can conclude that the given CFG is ambiguous. Okay, ambiguous in nature. And then you have to remove this. So your assignment is, what is the advantage and disadvantage of, note down this, okay? By Sunday, I'll be giving you a few more questions on assignment. With that question, you have to submit this assignment by next week. So today's question for assignment, I won't be repeating this one. Please note it down. What is the advantage and disadvantage of ambiguous grammar and unambiguous grammar? What is the advantage and disadvantage of ambiguous grammar? Or no, it will be quite confusing. I'll remove the second part. What is the advantage and disadvantages of ambiguous grammar? That's it. What is the advantage and disadvantage of ambiguous grammar? This is the first question. And the second question is how to convert or how to remove this ambiguity from a grammar. Second question is how to convert an ambiguous grammar to unambiguous grammar, or how to remove ambiguity from a grammar. So I'm giving you two questions. First one is what is the advantage and disadvantage of ambiguous grammar? Second question is how to convert a given ambiguous grammar to unambiguous grammar. That's it. Okay. Have you noted down? So by Sunday, I'll be uploading one assignment in the Google Classroom. With that, you have to submit it by next week. Okay, thank you.